Predictive modeling, machine learning, and AI all rely on an equation consisting of main effects and higher order effects. And while one can use those methods without understanding or comprehending the underlying equation, I feel that those that work in a scientific or engineering field wanting to use these methods should avoid these kind of black box approaches because they might lead to misunderstandings. It kind of comes down to that statistical significance is not the same as practical significance. If you want to learn what's inside this magic box of machine learning, stick around for a minute and I'll show you how it works. So imagine you are the proud owner of this here moving company and you have been really horrible at coming up with price estimations for your customers. So you have started gathering some data and now you want to use that data to predict how many hours a certain move will take based on 3 different parameters. So you have given how many boxes there were, how many large furniture there were, and whether or not there was an elevator at your disposal. So we want to use all of those 3 parameters in one equation. We want to look at their interactions and we want to look at whether or not they have curvatures. But let's take it slowly. Let's take it one step at a time. Here's an equation with just a single factor, and that factor were how many large furniture there was. And you can see that I start about 0.5 and I add 9 hours for every piano or couch that was to be moved. Now you can see I've added a quadratic term, which makes the effect of large even more dramatic as it now has that kind of curvature effect. The last thing is a little more difficult to explain, and it is also the thing that people often forget to take into account. It is the interactions between your factors. So I'm saying that more than just my factors or my x's have an effect on my output, they also affect each other, which is really annoying, but it's common. So if we look at this final graph, you can see that if there is an elevator, it takes about 3 hours less time than if there is not an elevator. So the effect of large is actually somewhat dependent on whether or not there's an elevator. Can we understand that? Well, yes. If I'm about to move a piano, there better be an elevator because that will save me a bunch of time. And if there's not an elevator, I need to adjust my equation to take that into account. So let's take all of that and combine it into one equation. So here you can see on the left I have how many hours there is to be moved. Then I have boxes, large, and whether or not there's an elevator. And now I can in real time change, depending on the customer's wishes or wants or needs. How many boxes do you need to be moving? How many pianos do you currently own? Is there an elevator at my disposal? And I can then see how long time that will take. Now let's change this to something else. Let's change this into factors that you are controlling in your lab or you are controlling in your production setup. Imagine doing this based on historical data or base this on a design of experiment. If you want to learn much more about this or you want to try and replicate what I do here, you can get a free trial of Jump by going to jump.com/statslikeJazz, and there will be links with further explanation of how I do this in the description. Thanks for watching, and I hope you gained something out of it.